Sierra Space, we believe in dreams worth chasing. That space is for everyone, and tenacity is how dreams are made real. Most of all, the real value we create in space is improving life on Earth. Sierra Space, dreams worth chasing.
Hello and welcome to the 2022 Spaceport America Cup. We are live with you at the vertical launch area. There is a rain delay. No teams are with us right now. Rains overnight and this morning have rendered the dirt roads impassable, and we are waiting for those roads to be safe to pass before we begin the launch portion of the event. Yesterday, teams were judged at the convention center. They showed off what they had built in poster sessions, performed a flight safety check, and the Ezra volunteer staff have been preparing the launch site. We are ready to launch out here, but there are no teams to launch since they are stuck on the other side of the dirt road. In principle, we are able to launch today for any teams who make it out here, but we will see when that is. We'll be showing you what the conditions are like out here, giving you a sense of what's going on in the vertical launch area, and doing a few interviews with the vendors and staff who are out here preparing. Right now we're looking at launch pad C. You can see all those launch rails ready to go, but no one on them yet. We hope to have some great shots of rocket liftoffs for you out here. And with us today, we have NASA Spaceflight doing some interviews. Let's go speak with him now.
We are doing our live stream test today. As you all probably are aware, we are in a rain delay, but we decided to go ahead and walk around and give you guys a tour just to give you updates. As far as I'm aware, the latest information we have is the grader is coming through the road. The holes are deep, but they're not mud, which is good news because that means we can just drain them of water and then grade them across and get the mud off there. So we'll find out any minute now whether or not the road's going to be open. In the meantime, I have our lovely person from NASA Spaceflight and Wildman, because I know most of you have been asking where he is. He's out here stuck with us.
It's actually Animal Motorworks.
Yeah, sorry.
There you go. It's okay.
Animal Motorworks.
It's Robert DeHate from Animal Motorworks, and we made our way out here yesterday, and we find ourselves out here this morning with all our friends, and it's great. It's rocketry, so we're used to this kind of weather situation. Certainly we all planned on heat and sun, and now we've got overcast and rain. So we just have to be dynamic in this situation. So we're hoping that the road comes open so that we can at least get some of the teams started. There's still a lot of motors that need to be prepped for launch. So today could be a good day to prep all the bonded motors so that they can dry. And we'll just turn this into a positive.
Awesome. And again, sorry.
It's okay.
All right. Well, you can see he's set up back here. We're in the middle of where base camp is supposed to be. This is our sponsored tent from Sierra Space that all the teams can come take a break at and visit with. I'm like, obviously not set up because we have very little staff. Oh, the only people that are here are the ones that camped over here last night. I do have a Subaru, so I was able to snake up there, get us some food, and brings a couple people down here to get us going. And then over there you have dumpsters, all of your bathroom restrooms. Down there is Da Vinci, and that's where we're going to go next and try to give you a cool up-close look to the MCC. Normally it's completely 100% off limits, locked door. Not even our Ezra president can go in there. It's they are very strict about that. So we're going to go ahead and go over there. So if you guys want to cut to a different video while we drive over, that would be fantastic.
All right, good deal. And really, we'll make sure, like, if there's any feedback, like, shoot us the feedback over there. This is not on y'all's camera anymore. Hopefully you've cut away, like he told you to cut away, right?
Okay, and here's what the weather is like at the VLA right now. We've got some great horizontal visibility at low altitude, but it is raining, mild winds, mild temperature. So it's a little humid, but things are pleasant out here for now. The cloud ceiling is low. 10,000 foot rockets are conceivable today if people manage to get out here. 30,000 foot rockets are more questionable based on the cloud cover right now. We'd also like to give you an overhead view of our site, give you a sense of what things are going to be like. Teams are going to be accessing this road from the upper left, working their way down to the safety line and launch control office. That's where teams will be parking, setting up their canopies, preparing their rocket, doing safety inspections, and recovering their rocket back to this point. That's the base camp. Then we have several possible launch sites. Bank A and B, furthest east. Bank C, the hybrid liquid pads, and the two-stage pads. You'll notice that each of these have a safety keep out around them, and something unique about this site that has been carefully done is that teams can be preparing to launch at one site while another site's active. We are hoping that will keep things flowing well. In any case, defer to the launch operations and flight safety people for specific instruction when you're out here launching your rockets. Our teams have submitted some great videos to us introducing themselves. Let's take a look.
AGH Space Systems is a student construction team operating since 2014 at AGH University of Science and Technology in Kraków, working on development of space industry technologies, building rockets, planetary rovers and stratospheric balloon gondolas. With the help of both the university and a variety of our sponsors, we continue with those endeavors and help spread knowledge about the space industry among others. AGH UST is also a part of the Universech project, thanks to which we are given many opportunities to expand our knowledge, gain experience and meet people from all over the world who are passionate about space technologies, like we are. 3TZK is a third iteration of our project, focused on developing a nylon-propelled hybrid rocket, designed to reach an apogee of 10,000 feet and beyond. Our goal for this year was to learn from the mistakes of our previous projects, further improve each and every subsystem, and obtain a reliable and reusable testing platform, which would enhance our research and testing capabilities.
In this year's project, to couple individual segments of our rocket, we decided to use radial excite joints, which allow us to improve rigidity of the structure and assemble subsystems independently, therefore decreasing the total assembly time. We want to make sure that our rocket will be able to withstand aerodynamic forces during the powered flight.
B4 engine is so far the biggest of the engines developed by us. It has been tested many times, and this year's development focused on implementing our new self-impinging injector and improving the reliability of this engine. Those changes lead to increase the overall thrust level and specific impulse.
We have a dual event recovery system.
drogue chute, and the main wing say parachute. They were designed and manufactured by members of our team. The problem of carrying out the test is that they should reflect the real flight conditions as much as possible. That's why we perform in drop and hardware in the loop simulated tests.
The rocket electronics team has put immense pressure on extending redundancy and system testing capabilities during this year's development. In effect, our modular distributed system is a safe, stable and even more versatile than its previous iterations.
The software team focused on testing and polishing the ground station software. We looked at possible changes to graphical user interface that would improve the ease of use and reduce the probability of sending unintentional commands. In addition, all throughout the year, we tested and enhanced the reliability of core application features.
This year, the team focus was put on research and development of composite materials. We prepared and tested a lot of samples. The data gained from this test allowed us to choose the most suitable material for the airframe and the fins, as well as it helped us develop composite materials simulations.
Our payload experiment is driven by the vision of aquaponic plant cultivation systems on Mars, and it's aiming at development of a safe way to transport Neocaridina davidi shrimps on board the rocket, a step necessary to set such a system outside of Earth. To alleviate their stress, shrimps will be sedated with anesthetics. It is the second iteration of this project, and since the last year, it got greatly upgraded in terms of mechanics and electronics. More tests on shrimps were conducted to gain repeatability of the sedation process, and this year, shrimps will have the chance to fly for the first time.
Members of our team strive to take any available opportunity for improving both our projects as well as their skills, abilities and knowledge. An open and friendly environment allows us to freely discuss all issues related to the design process, share our knowledge and thrive. We continuously try to take on even more complex challenges, such as designing and manufacturing a liquid propellant engine or conducting astrobiological research on cancer cells. Things that we do at AGH Space Systems are our way to work on our dreams and ideas, no matter how bold they are. See you in space.
We are the Atomic Aggies, New Mexico State's rocketry team.
We are the Case Rocket Team. My name is Maximus Ross.
My name is Russell.
Ava Abramson.
Ben Growalski.
Maddie Bartow.
I am the Spaceport America Cup competition lead.
I'm the Aerostructures lead.
I'm the payload sub-team lead.
I was our systems lead.
I was the president.
Our team is from the Case Western Reserve University. We are competing with our rocket named Lake Effect and our payload named Ice Cube in the 10,000-foot commercial off-the-shelf category.
We've worked extremely hard this year, and I think we've really come together as a team to build a rocket that we can all be proud of.
My name is Ert. I'm a sophomore student at Chulalongkorn University, and I'm the project manager overseeing the progress of the project.
My name is Boston. I am a sophomore student at Chulalongkorn University. I am in Flight Dynamic and Propulsion team. My task is to ensure that the rocket flies in the safe trajectories.
I'm Nats. I'm a sophomore student studying aerospace engineering. I'm the head of electronics and I oversee all electronics in the Cursor 1 rocket.
My name is Patrick. I'm the second year engineering student and I'm the deputy project manager. I look over the technical aspect of the rockets.
Hi, my name is Leslie and I'm currently the project manager for the PSP-SA team.
Hello, I'm Nathan Van Dam and I'm the lead engineer.
Hi, my name is JD. I am also the structures lead.
Hi, my name is John Carrington Warren and I'm currently the avionics and recovery team leader.
Hello, my name is Akarsh Sahai and I'm the current payload lead.
Hi, my name is Nick Fava and I'm the manufacturing lead.
The project for this year is Icarus.
We are ready for takeoff.
Hi, I'm Kevin Schultz, class of 2023 from Worcester Polytechnic Institute's High Power Rocket Club. I'm the team captain, which means I'm responsible for all team activities and operations.
Hi, I'm Troy Otter, class of 2022 from Worcester Polytechnic Institute's High Power Rocketry Club. As Rocket Division lead, I oversee the design, construction, and testing of our competition rocket.
Hi, I'm Jake Roller, class of 2023 from WPI's High Power Rocketry Club. I'm the payload division lead, which means I'm responsible for leading the team to develop and test the team's functional payload.
I'm the team captain.
I'm Jesse Davidson and I'm project manager.
Dr. Badman, co-lead of avionics.
I'm Matthew Vasiljevic and I work on avionics and body construction.
Nina Lucio and I was the co-lead of the payload and aerostructures.
I'm Hilary Dusky and I'm co-lead of payload and aerostructures.
Connor Van and I am parachutes and aerostructures co-lead.
Anthony DiGirolamo and I'm the avionics co-lead.
Jesse Putma, I'm aerostructures co-lead.
Give me all you've got if you're prepared to break the silence.
Hello, I'm Daniel Molidor. I am the project manager.
Hi, I'm Amy Keller. I am the launch operations lead.
Hey, I'm Ali Epping. I'm recovery operations officer.
Hey, I'm Alexander Pham. I'm the safety operations lead.
Hello, we are Waterloo Rocketry, a student design team from the University of Waterloo in Southern Ontario. I'm Zachariah Mears, a fourth-year engineering student and one of the team leads on Waterloo Rocketry.
My name is Delaney Diamond and I am a team co-lead and operations director of Waterloo Rocketry.
My name is Roman Kobitz. I'm one of the team leads for Waterloo Rocketry, and this year we're competing in the 30,000-foot Estrad hybrid category with Kraken of the Sky.
Hannah Cruz, Junior, Captain, Project Management and Vehicle Integration.
Jack Griggs, Senior, Aerostructures and Launch Operations Lead, responsible for building the rocket and launching the rocket.
Mike Panaro, Avionics Lead, Design, Development, and Integration of Avionics Projects.
Neha Chantapatla, Junior,
Payload and Safety Operations Lead, Payload Design, Test and Integration, and Safety Operations.
Gabe Mills, Sophomore, Recovery Lead, and my responsibility is to recover the rocket.
Animals to avoid in the New Mexico desert, or How to Minimize Pain and Suffering Part 2.
Hello Rocketeers and welcome to Spaceport America Cup 2022. One of the items we need to be concerned about here in the desert is wildlife. And the wildlife that isn't always obvious can be some of the most dangerous wildlife, like a rattlesnake curled up in a bush. That's why we wear our jeans. That's why we have closed-toe shoes and even boots if we can have them, because you never know where you might run into a snake like this one.
Other animals to watch out for. We have some fearsome looking but harmless creatures around here. Our best advice: wear boots, wear jeans, pay attention to your surroundings, and if it moves, leave it alone.
AGH Space Systems is a student construction team operating since 2014 at AGH University of Science and Technology in Kraków, working on development of space industry.
Project Andromeda is the fourth high-power rocket developed by ASAT and is selected to participate in the 10,000 feet coach solid category of the 2022 Spaceport America Cup in New Mexico. Let's get to know the rocket and its subsystems.
ASAT competes in SAC 2022 with the coach SRM. The main reasons are the challenge of the logistics for a European rocketry team, especially for the chemicals and the solid propellants, along with the fact that ASAT participates for the first time in person in Spaceport, striving for a successful launch by eliminating the risk of a SRAD motor. Its option came up through our selection methodology that has been developed by the propulsion subsystem based on the objectives and requirements of the mission.
The airframe of the rocket consists of carbon fiber nose cone, 3 carbon fiber tubes, 1 fiberglass tube for RF transparency, and 3 composite fins. All the internal and external parts are analyzed both using CFD and FEM analysis respectively. The analysis covers various velocities, angles of attack, and load factors in order to gain a better understanding of the aerodynamic behavior and structural integrity of the parts. Andromeda is 8.86 feet long and features a diameter of 5.86 inches. The rocket reaches a maximum velocity of 0.9 Mach while maintaining acceptable stability margins throughout the launch.
The rocket's recovery is achieved by a dual deployment event. At apogee, the payload, main and drogue chutes are deployed via both coach and strut ejection mechanisms. The drogue chute decelerates the vehicle at 85 feet per second. At 1500 feet, the main parachute will be pulled out of its deployment bag via tender-descender separation, allowing the rocket to reach a terminal velocity of 21 feet per second.
The payload subsystem carries out a scientific experiment to observe the effects of a rocket flight on a whole blood sample from a sickle cell anemia patient. Therefore, the 3-unit CubeSat houses a microscope-like structure with an action camera to record the changes that are caused to the red blood cells. During the ascent, the setup records the effects that hypergravity has on the red blood cells. When the rocket reaches its apogee, the payload is deployed and then recovered separately. During the descent, it investigates how the low oxygen pressures at high altitudes affect the red blood cells from the blood sample.
The avionics subsystem decided after the, let's say, not so successful recovery on Europe 2021 to take a step back and try to nail the basics. As the chance for in-flight testing are non-existing risk, we decided to use only coach recovery electronics and try to squeeze all the necessary sensors for our next flight computer on the payload's PCBs. This way we could aid them with their project while maintaining focus on our goal of creating a reliable flight computer.
Parallel to the technical work, ASAT's operation subsystem was tackling all the necessary logistic issues, ensuring the team's participation in the competition. Thus, the team aims for a very great experience in the first ever Greek presence to the final event of Spaceport America Cup.
AGH Space Systems is a student
Project
Hi, we are
My name is JD Inge. I'm a senior and president of the group.
My name is Jackson Kennedy. I'm vice president.
Hi, my name is Hannah Mark. I'm a senior. I'm the treasurer and co-avionics lead.
I am Patrick Wilson, a senior, the corporate outreach officer, and the recovery engineering lead.
My name is Oliver Gibson. I'm a senior, and I'm the propulsion and simulation lead.
I'm William Kim, junior and avionics lead.
My name is John Smalley. I'm a junior. I'm the structures lead, and we are.
And we are.
We are.
We are.
We are.
And we are Duke Aero. Founded in 2016, Aero is one of only a small few aerospace-focused groups on Duke University's campus. Because of this, our mission has always been to provide students with access to the aerospace field and the opportunity to use their classroom knowledge, classroom learning in an industry-relevant, hands-on manner. From a technical perspective, our group has flown 4 rockets since our founding in 2016, the most recent of which was an experimental 2-stage vehicle which has been flown and reflown for recruitment events both this year and last year. This year, our team has nearly tripled in size due to a big recruitment push in the fall. We're proud to present Coach 30K, our vehicle entry for this year's Spaceport America Cup. I'll be flying to 30,000 feet, carrying experimental payload measuring muon flux at altitude during the duration of the flight.
Our main goals with Coach 30K were to use our first ever carbon dioxide recovery deployment device and to bring a muon detecting payload to 30,000 feet.
You know, as the structures lead this year and the president next year of Duke Aero, after this launch at SAC in 2022, I'm really hoping to move into some student research stuff like altimeters and starting the process for researching a hybrid rocket motor that we can develop. As we're really reaching the limits of what we can with solid rocket motors, but I'm really excited to see how we're going to compete this year at SAC.
Duke Aero has meant so much to me, both in terms of professional development and community. One of my favorite Aero moments was our Friendsgiving, where we all brought food and just talked about rockets nonstop for 2 hours.
I'm Sam Savitt, I'm a rising sophomore, and being on the structures team for Aero this past year has shown me what it really means to be an engineer and to get into the nitty-gritty of design and manufacturing. And it's a hard feeling to beat, bringing a rocket out onto the pad that you know you helped build with your own hands, and I can't wait to make it happen with Coach 30K this year.
Hello, my name is Sage. I'm an incoming sophomore, and I joined Aero to gain hands-on engineering experience that I would be able to draw from once I started working in the aerospace field. But aside from that, I really enjoyed getting to know my teammates, and I think we work really well together.
Our team consists of 6 divisions: the recovery, the engine, the mechanics and avionics, electronics, payload and business. Let's give the floor for some of them.
Our engine was designed to deliver 13 kilonewton-seconds of total impulse. It is a hybrid engine. It burns nitrous oxide as an oxidizer and polypropylene and polyamide as fuel.
And not gonna lie, we love that sound.
Hi, in Crunched Rocket we are using a system based on scared reffing for dual event recovery. The main idea of reffing is to reduce the dimension of the parachute by pulling it with rope. Unreffing is about releasing the line and letting the canopy inflate to its full dimension.
Well, so the main purpose of the Amber project as a payload of R6 Simba rocket is to create an autonomous, modular and scalable platform to conduct scientific experiments in an astrobiotechnological nature.
We work on our project in many places. In Protolab 1 we prototype parts, work on electronics as well as software, and hold a team meetings. At Protolab 2, called Space for Makers, at the workshop of the Polish Rocket Association and at Space Force Company headquarters, we make mechanical parts and carry out pressure and engine tests.
My name is Ert. I'm a sophomore student at Chulalongkorn University, and I'm the project manager overseeing the progress of the project.
My name is Boston. I am a sophomore student at Chulalongkorn University. I am in Flight Dynamic and Propulsion team. My task is to ensure that the rocket flies in the safe trajectories.
I'm Nat. I'm a sophomore student studying aerospace engineering. I'm the head of electronics and I oversee all electronics in the Cursor 1 rocket.
My name is Patrick. I'm the second year engineering student and I'm the deputy project manager. I look over the technical aspect of the rockets.
We are from Chulalongkorn University, located in the middle of Bangkok, Thailand. The university was founded in 1917 and currently has various faculty focusing on multidisciplinary higher education. So for the club, CHA is abbreviated from Chulalongkorn University High Altitude Research Club. So the club was founded because of our common interest in aerospace engineering, the interest in rocketry. So we decided to form the club and try to compete in the Spaceport America Cup this year.
Cursor 1 or Chulalongkorn University Sounding Rocket 1 was developed for the 10K COTS category in the Spaceport America Cup 2022 competition. We employ the design, build, test, iterative method throughout the development. But although we have carefully planned out timelines of our rocket, we face many challenges in the delay in procurement of parts, both locally and internationally.
We found the competition on the internet, and of course, it is the world's largest intercollegiate rocketry competitions. Moreover, there is no team from Thailand ever compete in this competition before, so we decided that we want to be the first team from the Thailand that compete in these competitions. This year, we aim to compete in 10K COTS category with our rocket Cursor 1. And for the next year, our goal is to inspire the younger generations both in Thailand and in our university who have the interest in the rocketry field.
Hello everyone, my name is William True Jackson and I am the team captain for the GW Rocket team. I oversee rocket development and ensure that the team makes it to competition.
My name is Phoenix Price. I am this year's payload captain. I oversee the development of the payload and more specifically the Vulture systems.
Emily Stottinger. I am the recovery captain and our team ensures proper, safe, and successful recovery of the rocket.
My name is Amy Chang, and I am this year's propulsion captain. I ensure the safe build of the SRAD solid motor and assembly.
My name is Aiden Worthington. I am on the aerostructures team, and I work with the aerostructures leader in building the airframe.
My name is Mariam Abun Mahadi. I am a payload team member, and I'm working to ensure successful operation of Vultures.
We are the George Washington University rocketry team, and so our school is based out of DC, but we conduct a lot of our work, especially with the SRAD solid propellant motor, out in Culpeper, Virginia, with the help of our mentors, Ben and Elaine Russell. And so outside of working on the airframe, the payloads, and recovery here in DC, we also conduct testing out in Virginia throughout the year. And that is the basis for how we came to develop our design that we're presenting here at competition called Goldwinger. So on the GW rocketry team, we are all about producing our SRAD solid propellant motors that we've been doing for a few years now. And also we are big in making payloads that wow the judges at competition. And so what we intend to do this year is to continue that trend by not only putting together a few different SRAD motors and trying some different things out, but also attempting to do something that we have not done before, which is deploy 2 payloads out of a single rocket airframe. And that is the basis for our V1 design of Goldwinger that we launched in February, and what we were able to accomplish effectively with our V2 design in April that we will be launching here at competition.
I joined the rocket team because I thought it sounded cool, and I stayed because it's been a great opportunity for me to get hands-on experience working on a project and its full life cycle.
I joined the rocket team because I was intrigued by the process of building a rocket.
I joined the rocket team because it gave me an opportunity to hone my skills as a mechanical engineer.
I joined the rocket team because I wanted more hands-on experience with building a rocket and designing a project with a team.
I joined the rocket team because I wanted hands-on experience and I wanted to learn from the field that I would be entering.
The different members of our team joined for different reasons, but we've stuck around, especially through COVID and all the challenges that have come with it, for one simple reason: we love what we're doing and we want to keep this team alive for those that come after us, because we understand the value that this kind of enterprise brings to students, especially in a lack of other similar opportunities from coursework at the university. And so we are really appreciative of the folks at Ezra for being able to put this together and keep it going these many years. And we look forward to not only this competition, the first one back in person in 3 years, but we're also looking forward to continuing the success that we had in previous years and developing the team in new and exciting ways in the years to come.
I'm Rose Marois. I'm an undergrad student in industrial engineering, and I'm the team captain for the ETS rocket team, Rockets.
Hi everyone, my name is Joey. I'm an undergraduate student in mechanical engineering, and I'm the aerostructure lead for Rockets.
Hi, my name is Joey Langlais. I'm an undergrad student in mechanical engineering, and I'm the propulsion co-lead.
Hi, my name is Jean-Philippe. I'm an undergrad student in mechanical engineering, and I'm the propulsion co-lead for Rockets.
Hi, I'm Mathieu Gagnon. I'm an undergraduate in electrical engineering, and I'm the avionics lead at Rockets. L'École de technologie supérieure is an engineering school in Montreal, Quebec, founded in 1974. The school has 7 engineering programs and accounts for 1 out of every 4 engineers in Quebec. The school also has the largest student research center in North America, comprising of 30 scientific clubs. Rockets was founded in 2012 and is the only aerospace engineering club at ETS. We are the most decorated student rocketry club in Canada. Our club is comprised of 40 members, mostly newcomers, and we account for one of the largest clubs at ETS. All our rockets bear the names of Inuktitut animals to pay homage to the Native American tribes of Canada. This year we decided to participate in the 30,000 feet COTS category, similar to 2018 and 2019 since we are mostly comprised of new members and would like to place first in our category. Our goal is to advance the aerospace industry and develop new technologies for rocket and space endeavors.
So for this year's testing, we decided to test 3 major components. The first one being the cable cutter. In 2019, the parachute actually opened at the apogee because the zip tie was too small. So we got a bigger zip tie and need to test the cable cutter to see if they cut the zip tie properly. Then the second test is a traction test for the bulkheads because we redesigned them completely. So we need to see if they can resist the charges during flight, after flight, and at the ejection, of course. Talking of ejection, that's the last test we are going to perform. This year we decided to do the separation at the nose cone instead of just after the booster tube. So we need to test this to make sure the nose cone ejects properly together with the parachute coming out. We have one main challenge. As said before, once again, as the team being composed of almost strictly new members, so that's the main challenge we have to face, having almost no members that have competition experience. So that's what we want to achieve. The second challenge we want to do is to be able to implement the different optimization projects into the new rocket.
For this year, we optimized our bulkheads using topological and geometrical optimization. Also, we used finite element analysis. We also developed an algorithm to optimize our fins geometry and help us reach the 30,000 feet apogee. We achieved some great results so far thanks to our sponsors who helped us with the manufacturing techniques. In the name of Club Rockets, thanks for watching this video and see you on the field.
Hello, my name is Devin Langford, and I'm the Solid Chief Engineer from Missouri University of Science and Technology's Rocket Design Team. Missouri S&T is located in Rollo, Missouri, about an hour south of Jefferson City. The team operates out of the Cummert Student Design Center located on campus.
To meet the Spaceport America Cup challenge, the team plans to compete in the 30K COTS division in the 2022 competition. Our rocket forward up to dawn is mostly made out of carbon fiber and fiberglass composites and stands a total height of 9 feet 10 inches. Fully loaded, Dawn weighs roughly 80.5 pounds and will reach a top speed of Mach 1.6 or 1,766 feet per second. We had our fins cut from a high-strength carbon sheet and have done a tip-to-tip layup to add an additional layer of carbon. The rocket features a dual-deploy parachute system with ejection charges triggered by our avionics system.
The avionics system uses a Raven 4 as our primary and a television V3 as our secondary. Our payload consists of a custom payload structure that will handle telemetry, data collection, charges, payload, and power parts. The goal of this payload is to help our understanding of board design and component usage to hopefully one day design a system that will make it to space.
The team has experienced many challenges over the past year. Some of these challenges included moving back to in-person, orders being delayed due to the current economic climate, electronic chip shortages, and a lack of experience with mixing propellant. At the start of this year, the team wanted to design, build, and fly our own SRAD motor. However, this was a huge obstacle, and the team decided it would be best to switch to a COTS Cicerone 03400 motor.
Even with these setbacks, it is more important than ever for us to attend competition. The rocket design team has been participating in the IRAC competition since we started in 2016. We strive to continue to offer opportunities to S&T students and foster the interest in rocketry in this new age of space. We're excited to come to New Mexico and show you what we learned.
Okay, so let's give an overview of the subsystems of the rocket Birkeland.
To minimize drag during supersonic flight, the airframe follows the von Karman ogive. The airframe is composed out of two halves, the forward and the aft airframe. These sections are made out of fiberglass and carbon fiber, made with a production method called filament winding, as we can see here. Now for the inside. When a rocket reaches apogee, the SRAD pressure-based separation system initiates, pressurizing the recovery bay, breaking the hairpins, allowing the rocket to separate. This separation allows for drogue chute deployment, and the system is reusable in its entirety. The main chute release system is a lock and release system developed by Propulse NTNU. It consists of two docking plates acting as an attachment point for a set of release arms, as well as both parachutes.
The main purpose of the payload experiment is to measure the vibrations of the rocket and find ways to dampen them. The study will be to test the effects of moon gel as a vibration dampener. The two IMUs will be mounted in parallel, one with moon gel and one without.
The CFD has shown that both the tapering of the boat tail and the fins are great for supersonic flight. We ended up with a trapezoidal shape for the fins, not only for the aerodynamic properties, but also for reducing the probability of breakage from touchdown.
First of all, I am very proud of the team and the achievements and results they have gained throughout these 8 months. That is very limited time in contrast with the 40 months that we had last year with Stettin. In one way, it has been quite stressful. But also very rewarding, and to see the development of the members and also us in the board and the project itself.
America, the vertical launch area. John Galloway with NASA Spaceflight here, out hanging out with some of the judges that will be judging the competition. If rockets ever show up here, we had some weather delays this morning. We talked about that a little bit earlier. The road conditions were not good at all, and we just literally couldn't get the teams with their rockets and all their gear out here. The range, I think, is ready to go. I mean, it sounds like range control is ready to start launching rockets. It's just hard to launch rockets if you don't actually have any rockets to launch. So let's introduce our judges here really quickly. Y'all are volunteers, right? Yourself.
Yeah, Melissa Mecca.
I'm Chris Sakala. Brandon Vienna.
Yeah, we're here from Aerojet Rocketdyne in West Palm Beach, Florida, to volunteer with Ezra to judge the students' projects.
All right. And I'm going to ask really quickly, can y'all hear us okay? Do we need to be louder or softer or whatever? Just make hand motions if we need to increase the volume or whatever. We're very fast and loose out here, but y'all had an opportunity to try and get over here up the road. Would you bring like a tank, a Jeep, or what?
Yeah.
Jeep Wrangler rental.
I was the only one smart enough to get a four-wheel, I guess one of the only ones to get a four-wheel drive, so we thought we'd take advantage of the, I guess, conditions with the Jeep and see if we could have some fun on the way out here.
To be fair, I thought when we did the initial judge meeting, I thought they said the first right after you see the big spin wheel launcher, and I was like, oh, I think it's there, so we turn right, and I was like, well, this is pretty. We just never turned around. Yeah, we just kept on turning around.
Just kept going. We're like, I think it's that way. Let's just go in there.
Yeah. We started seeing the spaceport building, and we just kept on going until we got closer.
Yeah. Stand on top of the Jeep and just look.
We actually saw it from the top of that hill over there. We knew where we were.
No kidding. Yeah. So tell us a little bit about the judges. Like, we didn't practice this or have a script or anything, but what is involved with judging the launches? Do y'all each have a specialty? Do y'all get together like in a huddle and talk about the rocket behind their back? Like, how do you actually judge?
Well, from what I understand is we're looking for some sort of checklist where they go through and make sure all the components of the rockets are assembled and that they're following any like safety procedures. Beyond that, I don't.
We're interested in their construction, the presentation skills, the actual overall performance. We don't judge the actual criteria, but whether the rocket works or not is obviously a criteria that we evaluate.
Yeah.
And also just looking for the next generation engineer.
Excellent. Have any special thing you look at for the rockets, or?
So, yeah, just making sure that their construction, their quality is good. Yesterday, just went over, with the teams what they plan on doing when they come out here, and then we wanted to make sure when they come out here today that we see how they assemble a rocket and making sure that they're going through all their safety procedures, how they should be.
Did y'all have a chance to walk around? There was like a rocket fair at the conference center back in town.
Yeah.
Did y'all get a chance to walk around and talk to teams yesterday?
Yeah, that was part of the judging. We asked them some basic design questions and such, but I like to ask, what's your biggest challenge that you encountered, or what are you most proud of on your rocket? And a lot of the teams would talk about the effort, like pulling together, while being a student and undertaking such a great task of putting together a rocket. So I was happy to see all the team spirit. They're very excited to be here, and they work pretty hard to put these rockets together.
It's always a thing because they're full-time students who are getting their whole-on education, and then they're also working on this rocket in, I guess, their free time, right? I think we could put free time in air quotes. Y'all design rockets for a living all day long. You don't also try to go to school at the same time, and it's tough enough. But for the students to actually be doing the school part of their education and also have time to work on the rockets,
it's impressive.
Yeah,
it's very impressive.
I wonder if they can hear that ATV going by.
They can hear the generator.
All right, cool.
One of the biggest challenges also, obviously, our whole world has been challenged over the last couple of years with the pandemic and all. And a lot of these projects started years ago, and they're finally getting to come through. So it's a lot of the guys that are leading the teams have already graduated, and they're still super volunteering. So it's a lot of effort from all teams.
Well, what's really amazing is this is an international competition, and they've been able to come up with unique solutions that they've been able to work through the years, and they all have this unique solution, and we're hopefully going to be able to see how they attack that problem.
Yeah, well, hopefully we actually get the road cleared up. The weather's not terrible right now.
No, it's cooler.
It's nice and cool.
Yeah, it's a lot less hot than it was in years past. But I don't know the cloud level right now. Like, could they even launch if they could get the people out here? I don't know how high these clouds are.
I think we're limited to 10,000 feet.
Yeah, they're shooting for different altitude targets, and you can't like punch through the clouds and lose visual on the rocket. That's sort of a thing, as it turns out. But I don't know if they would be launching anyways with the cloud cover this year. But the road was not doing too good. They kept sort of slipping back. It was 1 o'clock last update we got. If I'm not mistaken, it's past 1 o'clock now.
Yeah, we're a little ways past.
Yeah, so we're way past 1 o'clock now. I haven't got any more information or any official statement on, are they flying today? Are they flying tomorrow? I mean, right now there's no tents here. There are no rockets here. The students are still either all the way back in town, or there was a bit of a staging area up at the paved parking lot earlier, but we haven't got any official word on whether we're going to be launching or not. But anyways,
weather's supposed to clear. Maybe tomorrow will be good. Yep. Coffee and a sunrise and a rocket launch.
There you go. Where you have to roll out at like 4 a.m. to get here for
pretty much
the sun to come up.
Yep.
But I think for now we'll go ahead and turn it back to the live stream crew. We didn't plan this out or anything. There's not like a run of show. I hope you have a video to show. If you do so, go ahead and do it. But with our judges here volunteering, thank you all so much for talking to us for a little bit.
Thank you for having us.
Pleasure.
Cool. Now we just awkwardly stand.
Thanks, team. Putting a finer point on those weather observation. We continue to have good visibility at ground level, with rain coming in and out, going from non-existent to barely perceptible. You just saw that present weather update at the official weather station at the horizontal launch area. There remains significant cloud cover. The key rule to keep in mind is that rockets may not enter a cloud. That is a safety rule. So we will never launch a rocket higher than the cloud ceiling.
Hello, my name is Bartosz Buda.
I'm Piotr Zacholski.
My name is Luisa.
Max Falbierski.
I'm Lukas Kozak.
Wojciech Kubiak. Łukasz Szypa.
Hello, my name is Bartosz Ziegler and I am the faculty advisor of Put Rocket Lab.
I'm studying safety engineering on the third year.
I'm studying mechatronics,
automatics, control and robotics,
aerospace engineering.
I'm a graduate student of automatics and robotics.
Graduated engineer in computer science.
I'm an employee of Institute of Thermal Energy and I have a PhD in turbomachinery.
In the team, I'm the chairman of Put Rocket Lab.
I'm leader of propellant department.
Financial coordinator and leader of promotion.
Electronics department section leader.
And I'm a leader of IT department.
I'm responsible for manufacturing, assembly, integration and testing department.
My team is responsible for avionics, ground equipment and user interface.
Field development and manufacturing for Hexa 2+.
Design and analysis of our rocket subsystem.
Development and designing all the electronics hardware used in the avionics and ground equipment.
I support the team mostly in propulsion design and external aerodynamics, and of course I sign on all the papers.
Poznań is located in the western region of Poland overlooking the majestic Warta River. We are the fifth largest city in the country with regards to our local population, which reaches over 500,000 inhabitants. There are over 25 different tertiary education institutions that are found in Poznań. The Poznań University of Technology is one of the most prominent universities, welcoming over 16,000 students. For many years now, PUT has remained in the top 5 technical universities in the entire country. The Poznań University of Technology places great emphasis on a practical approach in education, and PUT Rocket Lab is a brilliant example of such policy. Students are allowed to further the knowledge in various fields independently with the guidance of the top quality scientists. For the past 5 years, PUT Rocket Lab has undertaken numerous studies and endeavors in the science of rocketry. This has led PUT Rocket Lab to a position of one of the most ambitious projects in the country. This year's project is called Hexa 2+. It's a one-stage rocket with a hybrid engine system, which is a noteworthy improvement of its predecessor, Hexa 2. The entire construction has a 4.35 meters length and 160 millimeters diameter. Rocket takeoff weight is 62 kilograms. The entire design was built out of an aluminum container for our oxidant, as well as other composite structures. The composites we use are mainly carbon or glass fiber reinforced with an epoxy resin. In the moment of takeoff, our ingeniously designed engine called Broomstick 2+ is geared into action. The fuel was coined from a mixture of microcrystalline paraffin wax and polyethylene at a low density. The oxidant used is nitrous oxide. With great pride, we can say that we, as students, created the sturdiest hybrid rocket engine in Poland. During the stationary test, the total impulse achieved yielded a surprising 40,955 Newton-seconds and a peak thrust of 4.8 kilonewtons. Moreover, we also designed a custom avionics system. It is responsible, among others, for detecting the apogee of the flight or initiating the return process of the rocket. The data from the sensors are continuously sent to the ground station with the use of LoRa technology. Hexa 2+ returns to the Earth with the assistance of a two-stage recovery system. During the fall, the decelerating parachute opens up with a diameter of 1050 mm. Followingly, a couple of hundred meters above the surface, the master section of the parachute is released with a diameter of 3250 mm. Our main objective is not to just build rockets. It is to effectively master our engineering skills whilst sharing our passion with others. We aspire to elucidate the concept of rocket engineering and cosmic technologies. Thus, we present ourselves at various events, international fairs, as well as conferences. We hope that our passion for rocketry will inspire others, that it will be a motivational force to achieve the unimaginable. PUT Rocket Lab depends on people coming from different backgrounds. We study diverse degrees, we have many varying passions, we prefer different types of cuisine, but one thing has brought us together. It's our common goal that not so long ago seemed a figment of our imagination. This goal has come to life, and it's ready to fly. That is Hexa 2+.
Team 68. PUT Rocket Lab.
Hi, my name is Leslie and I'm currently the project manager for the PSP SA team.
Hello, I'm Nathan Van Dam, and I'm the lead engineer.
Hi, my name is JD. I am also the structures lead.
Hi, my name is John Carrington Warren, and I am currently the avionics and recovery team leader.
Hello, my name is Akarsh Sahai, and I'm the current payload lead.
Hi, my name is Nick Fava, and I'm the manufacturing lead.
The project for this year is Icarus.
And we are ready for takeoff.
Our team is part of the larger Purdue Space Program SEDS chapter, also known as PSP, which has been around since 1994. Currently, we are the largest SEDS chapter in the country. There are 7 total teams within PSP, all dedicated to innovation and the empowerment of students. Prior to our team being formed, the PSP Solids team attended the Spaceport competition. At the end of 2020, the Solids team disbanded and resources were distributed among the other PSP teams. In the fall of 2021, a prior Solids team member led the recruitment for a new team, focused solely on attending the Spaceport America competition. This team, known as PSP-SA, is the one currently being introduced to you. With almost entirely underclassmen as members, perseverance has proven to be the most important skill for us to have.
The project for this year is titled Icarus. The team chose this name because it represents our determination to reach for the stars while still remaining humble and enjoying rocketry. For the majority of fall 2021, we conducted research on how to build a rocket. We utilized our mentors and peers much during this time because the majority of us didn't know where to begin. Each individual sub had its own tasks and systems to research. The structures team had to learn how to use open rocket software and also had to learn what components were necessary to have a functional rocket. The payload team brainstormed functional payload ideas using previous projects as a guide. The avionics and recovery team formulated base plans for how the electronics and recovery systems function. The manufacturing team learned how to use CAD and CAM software with other machining techniques.
After having our preliminary design initially reviewed by our peers, we made revisions using our peers' feedback as we further developed our plans. These revisions were subsequently tested theoretically to ensure that changes would actually improve our design. Much of the manufacturing of the rocket would be split between the Purdue Aerospace Sciences Lab and the Bechtel Innovation Design Center.
We want to engage with peers from around the world and gain new perspectives on rocketry.
We want to take what we've learned in the classroom and apply it to an actual real-life project.
We want to showcase our knowledge and skills that we have picked up as a team over the last year.
We want to test our competence as a newly formed team.
We want to lay the groundwork for future generations of our team to build on.
As engineers, problem solvers, and students, this project has taught us more than we could have hoped for. Though our team is young, we anticipate doing a lot more in the future, even though we've come so far already.
We are WPI's High-Powered Rocketry Club. With over 100 student members, we devote ourselves to the research, development, and launch of a high-powered rocket and payload system. Worcester Polytechnic Institute is a private university located in Worcester, Massachusetts, implementing an innovative approach to undergraduate education focused on project-based learning. The WPI motto, Lehre und Kunst, or Theory and Practice, illustrates the university's emphasis on encouraging students to collaborate and build confidence, leadership, and critical thinking skills. WPI realizes it's not just what students learn, but how they learn that proves invaluable professionally and personally for a lifetime. At WPI, we've realized a need to extend ourselves beyond the classroom and embody our motto of theory and practice. We do this by engaging in holistic, challenging engineering experiences as competitors in high-level rocketry competitions, all while emphasizing member education and team collaboration. We began our journey in 2019, traveling to Huntsville, Alabama to compete in NASA's University Student Launch Initiative. Although our rocket experienced failure at 800 feet due to a defect in our commercial motor, the experience exposed our potential as WPI's premier rocketry team. The preceding 2 years saw us continuing to compete in NASA's USLI up until now, where we have the privilege of competing in the Intercollegiate Rocket Engineering Competition. Composed of both a rocket and payload division, our team has conceived, designed, tested, and constructed both a rocket, call name Altair, capable of reaching a target altitude of 10,000 feet, and a quadcopter payload, call name Tarzed, capable of autonomous flight to locate our launch vehicle upon landing. Altair's design saw a novel threaded coupling system for easy connection and disconnection of our airframe components, an air brake system with an integrated controls design, a single-ended recovery deployment with CO2 cartridges, custom printed circuit boards for controlling, sensing, telemetry, and power, and a novel ground station for receiving and displaying telemetry data. Tarzed, on the other hand, consists of a retention system which is jettisoned from Altair at 1,400 feet during its recovery sequence. The system then lands safely, initiates self-leveling, deploys its folding quadcopter arms, and releases from the retention system to locate Altair through a continuous signal emitted from the rocket. As for why we do what we do,
I feel like this is such an important and cool project to be a part of. That's why I feel so inspired every day, is because we are always pushing the boundaries of what we can do, we're always trying new things, and we're always having fun as a group at the same time, which is really such a great collaborative environment that I just always feel like I want to be a part of. To get to do such innovative tasks with each other and always just be pushing ourselves is just such a cool thing, and it's so inspiring to see other people feel proud of what they do and to see how they've succeeded in their own goals, which is why I love helping and supporting all the other people in this project, and I hope to continue to do so.
The Rutgers Rocket Propulsion Lab team is representing Rutgers University in New Jersey as Team 83.
My name is Matthew Huang.
My name is Anish Seth.
My name is William Freitag.
My name is Keith O'Donnell.
My name is Spiro Clementos.
Hi, my name is Nicholas Henson.
My name is Aditya Anicode.
My name is Ariana Arcilla.
Our project name is the Model of Navigational Kinematic Egress, or MONKEY for short. It's a two-stage rocket in the 30K COTS category, deploying a quadcopter as a payload.
We are using an M2500T for our first stage. That has a specific impulse of 9,671. Then for our second stage, we are using an Aerotech M1350, which has a specific impulse of 5,178.2 Newton per second.
Our project is a SRAD student-built quadcopter with a LiPo power source and COTS flight controllers and ESCs.
Recently, our recovery team has been developing a new CO2 ejection system, and we've been improving our parachute manufacture process. We're going to be flying 2 RRC-3s in the sustainer section, as well as a MissileWorks GPS for GPS navigation, as well as in the booster section, we'll be flying 2 more RRC-3s and a Telemega for our GPS system.
My role on Rutgers Rocket Propulsion Lab is the telemetry and recovery lead, and my responsibilities include designing a PCB for all our telemetry electronics for the entire telemetry suite, as well as designing a combined telemetry and AV bay for the sustainer section of our rocket. In addition, I work on the single bay dual deployment device for our booster section of the rocket, as well as our regular dual deployment setup for the sustainer section of our rocket.
As a team, telemetry works on a redundant module for collecting data in flight, processing it on the ground, and visualizing it as well. We're gathering stuff like GPS, barometric pressure, temperature, acceleration, orientation, everything that we'll need so that we can know what happened in the rocket, where it went, and then, make good visualizations of that data.
Primarily, my job focuses on designing the aerodynamic components for the rocket, as well as constructing and building components related to 3D printing, as well as all of our bulkhead retention systems and drilling holes in our fiberglass body tubes.
The simulation software that we are using is called ANSYS, and it's used to simulate various stresses and strains on the rocket body tubes. As for 3D printing, we're primarily using a material called onyx, which is a composition of nylon and carbon fiber.
Thank you to our sponsors and people who have helped us along the way. We're excited to show you our rocket.
Subscribe to our channel to keep up with all our latest content and launches. For more of Rutgers RPL, check out our social media links, as well as our website at www.rutgersrpl.com.
Dreamers. We are dreamers who have set our eyes on the heavens. Dreamers who yearn at the opportunity to reach out. To reach out and touch the heavens. And when you take us dreamers and put them together, you get something more. More than just a collection of people. More than just the summation of their strengths. Put them together and you reach farther. You achieve more. Add collaboration, dedication, problem solving, science, engineering, and craftsmanship, and aim those at the heavens. Well, now you have a team. A rocket team. Here at The Ohio State University, we have put those things together, brought students from around the globe with dreams of making the impossible possible. Visions of student-led spaceflight and rocketry are our heavens, and we are reaching strong. We are more than just a rocket team. We are BSLI. Reach with us.
Hello, I'm Vanmita Adimulam, currently a third-year aerospace engineering student. So as a project manager and the team leader, I oversee and manage the entire project.
University of Science Malaysia is a public research university in the country. Our school is one of the best leading providers of aerospace engineering education and research. Founded in 1969, it is among the oldest institute of higher learning in the country. With around 28,300 postgraduate and undergraduate students in 2009, USN is one of the largest universities in terms of enrollment in the country. We came across this competition through our advisor, Dr. Noor Elmi. Then we formed this group of 11 undergrad students. We also have tremendous support from our experienced TRA mentor, Julian, in giving us technical advice about rocketry. Our school has provided ample support from financial aid to providing facilities to design and manufacture our rocket. We are the first team, not only from our school, but also in the nation to launch a student-made high-powered rocketry.
HEBA rocket consists of four main parts, which are airframes, nose cone, couplers and fins, where the airframes were fabricated while the nose cone, couplers and fins were bought from local and international markets. The diameter of the rocket is 6.15 inches for outer, 6 inches for inner, with total length of 130 inches. The fabrication of the rocket was done by hand layer process using woven roving fiberglass and epoxy resins required for it. A 6-inch outer diameter aluminum tube was used as a mandrel for the fabrication of the body tube.
The propulsion system of Hebat uses a reloadable composite aerotech motor M2000R98mm. The motor has a length of 28.82 inches and it uses the red line propellant. The motor delivers a 4 seconds burn time and the maximum thrust can reach up to 23-27 Newton. The whole propulsion subsystem weighs about 19.81 pound. For centering rings, plywood and fiberglass were used to fabricate them. In order to enhance the strength of the centering rings, fiberglass was sandwiched in between two pieces of plywood rings and rocket epoxy is used to attach them together.
In Payload Team, we designed and built a nanosatellite, which collects and transmits environmental data to the ground station. The nanosatellite weighs 3.16 pounds with a height of 13.78 inches and a diameter of 5.85 inches. The nanosat will carry a 5.04 pounds of dummy block, metal plate engraved with names of fund contributors, medals with company sponsors, a little astronaut, and a V50 camera that will record the launch of the rocket.
Hebat rocket requires a recovery system for us to retrieve back the rocket safely after its flight. The rocket consists of a dual deployment system which consists of a main parachute and a drop parachute. Here, the avionics system plays a role to deploy those parachutes at selected altitude. At apogee, the Altus Metrum Easy Mini and the missile's RRC-3 will eject black powder to release drop parachute. The drop parachute will reduce rocket descent speed to 60.
AGH Space Systems is a student construction team operating since.
Project Andromeda is the fourth high-power rocket developed by ASAT and is selected to participate in the 10,000 feet.
Hi, we are the Case Rocket team. My name is Maximus Ross.
My name is Russell.
Ava Abramson.
Ben Kowalski.
Maddie Barto. I am a senior.
Medals with company sponsors, a little astronaut, and a V50 camera that will record the launch of the rocket.
Hebat rocket requires a recovery system for us to retrieve back the rocket safely after its flight. The rocket consists of a dual deployment system which consists of a main parachute and a drop parachute. Here, the avionics system plays a role to deploy those parachutes at selected altitude. At apogee, the Altus Metrum Easy Mini and the missile's RRC-3 will eject black powder to release drop parachute. The drop parachute will reduce rocket descent speed to 65 feet per second. At 900 feet upon descent, the main parachute will come out and reduce rocket descent speed to 70 feet per second and make a safe landing.
So our purpose of participation in Spaceport America Cup is to gain the experience of building and launching a high-powered rocket. Because as Malaysians, we have never gained such experiences here, and I believe that Spaceport America Cup is the best and a golden opportunity for us. Not only that, we also want to engage with other rocketeers from all around the world who come to Spaceport America Cup to demonstrate and launch their project. So with such experience and knowledge, I believe that we are able to kickstart Malaysia's rocketry development and also set a benchmark for the university students here in rocketry field. So with that, we from WOW Rocketry USM looking forward for this year's Spaceport America Cup.
Hi there, Spaceport America. We are the student organization of Aerospace Research, or SOAR, from the University of Calgary, Canada. Our school has grown to be known for our research, and that doesn't stop at aerospace. Established in 2015, originally in the physics department, SOAR was an astronomy and small model rocket-based group. It wasn't until an ambitious undergraduate student, Colin Hill, that SOAR was propelled into the engineering team it still is today. With help from the physics group and a capstone project of a hybrid rocket, Colin revamped SOAR and with his capstone team continued to work alongside Dr. Craig Johansson to develop a rocket research lab at the university through his master's and PhD degrees. In addition to this mentorship, Dr. Johansson is gracious enough to allow us to test our motors at his testing facility at the Rothney Observatory just south of Calgary. Following SOAR's first competing rocket, a hybrid named Atlantis I that participated in SAC in 2017, the conceptualization of Osprey 1, a solid rocket, began. This is the rocket we will be competing with this week, and it carries years of hard work and countless hours of sweat and tears. Thankfully, no blood.
The length of the rocket is around 10.5 feet with a diameter of 6 inches.
Through-the-wall fins help increase the strength of the joint. Our parabolic, 3D printed isogrid nose cone is reinforced with fiberglass. The aluminum tip serves as a heatsink to avoid deformation of the ABS plastic.
Osprey will use a Cesaroni Technologies N2200 5-grain motor from the Pro 98 series. It'll have an average thrust of 2,162 newtons, a peak thrust of 2,756 newtons, with a burn time of 5.58 seconds.
At the heart of Osprey 1 is our proprietary flight computer. The Andromeda Avionics System is a cluster of 4 custom PCBs. This gathers data on acceleration, atmospheric pressure, and GPS positioning. Simultaneously, flight data is relayed to our ground systems through a high bandwidth 2.4 GHz radio system and a long range 433 MHz radio.
The scientific payload for Osprey 1 is a 4 kg 2U CubeSat designed for modeling the troposphere. Carbon dioxide humidity, density, temperature, and pressure will be profiled using a venting system, and these measurements can be used to validate and create basic atmospheric pressure models.
Now that you know where we come from and about our rocket, here's the big question. Why? And I'll take you to our team members to answer that question.
Yeah, I joined because I've, since an early age, had a passion for aerospace, and I wanted to connect with people that are like-minded in that field.
I always really liked building rockets as a kid growing up. I built my own solid rockets for a while, and I wanted to take the opportunity to join a team that would let me build larger rockets as well as rockets powered by hybrid propellant combinations.
I joined SOAR so that I can learn and apply my mechanical skills. I joined SOAR to get better at making rockets.
I joined SOAR because, ever since as a kid I saw Jupiter through a telescope for the first time. I wanted to be part of the space industry. So I joined in my first year to grab a piece of that.
So in high school I did a lot of competitive robotics teams, and when I came to university I was missing a bunch of that. So in the second year I discovered SOAR and I was like, hey, engineering. Place to practice software, electronics, tons of stuff.
I actually knew nothing about the stuff that we're doing right now, and it's just been amazing working with all the people here. They're so enthusiastic. Matt here has taught me everything I know about everything, and I just hope to be a mentor to other students in the future. Okay.
And what are you excited about for college?
I'm excited to see our rocket launch and hit apogee, and I'm also super excited to network with a bunch of other teams that are there and use the lessons we learned there to improve our next rockets.
So I'm super excited to go see other teams and the designs they have, the ideas they have, that will then inspire our team to build a better rocket next year.
To see how we perform under pressure. I'm insanely excited to go to comp just to win, because that's what we're doing, is winning.
I'm most excited for the wicked sunburn I'm going to be getting at competition.
I am super looking forward to getting this rocket off the ground. We've been working on it for so long. I've been on the scene for like 4 years now. It's going to be super fun.
Yeah, and a lot of our technical components are just proof of concepts for future rockets, so it'd be really nice to see them working and everything coming together.
Good soggy afternoon, everyone. This is Chris Lopez, Director of Site Operations at Spaceport America.
Hey, I'm Cliff Olmstead, President of Ezra.
And we've got some news for you on an update for operations here at Spaceport America Cup on this soggy Wednesday afternoon. We had an anomaly of quite a bit of rain for this area overnight. It caused quite a few problems. Road conditions are extremely slippery, slick, and that equals danger. Both for rockets and just for folks safely traveling out here. We really need to just give a big thank you, just as the rocketry community has come together and supported this event. The local community of Sierra County, Las Cruces, Truth or Consequences, they have come together to try to help us get back in gear and help get past this rain. So Sierra County, big thank you. You guys are fabulous. You guys are fabulous out there. Thanks for all the support. But it is still very, very soggy. I know many of you are looking for kind of launch conditions updates, and with that, we'll toss it over to the folks that know folks that know more about launches than I do.
The man in charge.
There you go.
Yep. So we've really assessed the conditions. We drove the road. We've looked at the options. It's actually currently sprinkling here now. Based on that, we are canceling flight operations for today, so all teams are not permitted to come to the VLA today. But what we will do is we're going to open the gate at 4 a.m. We've talked to our friends in Fiore Security. They're going to open the gate for us at 4 a.m. to come and get set up. We'll do flight ops as soon as we can within reason, and that's all weather dependent. So if we get another torrential downpour again at night, then we'll have to adjust. So I appreciate your flexibility. I appreciate the teams that came out and waited. I know it's it's always kind of nerve-wracking and stressful to wait, and these things are just out of our control. So thanks for your understanding. We'll see you tomorrow at 4 a.m.
Yeah, and speaking of out of our control, Cliff, this is not the first time launch operations have been affected by weather.
That is very true.
It does happen periodically. This is the rocketry business. But the enthusiasm that continues, we really appreciate it. We know it's not the news you wanted, but out of an abundance of caution and out of an abundance of wanting to wish you the best possible success you could have here at Spaceport America Cup, we feel this was the right decision to go out and delay for the day, and we know that'll set you up for some great success this week.
Yeah.
In the morning, bring the extra coffee, folks.
I'm gonna add one more thing to that too. Teams, get your rockets ready. Be prepared. Do everything you need to do so that when you get out here and set up, you can set up quickly, efficiently, get your rockets ready to get through inspection, and we'll get you in there as soon as we can.
Let them know we're going to do some more interviews.
And we're going to do some more interviews coming up later.
Yep. And keep paying attention to your social media, folks. Team captains, community members watching this. We are getting live updates out there on Facebook and HeroX. We will send updates accordingly. So stay safe, everybody. Stay plugged in. And welcome to the rocketry business. We'll see you soon.
Carry on.
You can cut.
Okay, welcome to Spaceport America Cup. This is Cliff Olmstead, president of Vesra. For those of you that have been tuning in, thank you. Thank you for watching the live stream. We're just getting set up with that. You'll notice there's no teams here currently. You'll also notice we've got a note there that says we're retrying tomorrow at 4 a.m. Gates will open at 4 a.m. So based on the weather conditions that we have right now and based on the road conditions, we are not allowing teams to come and do setup today, Wednesday. We will instead open the gates at 4 a.m. Tomorrow on Thursday. And the reason for that is just conditions. We just, we're not able to fly with the low cloud cover, and the roads are improving, but not good enough to allow hundreds of cars to take them. So we hope certainly you'll join us in the morning. Be prepared. Take time to review your checklists, review your equipment, review your rocket, identify things that need to be fixed so that when you get out here, your setup can be as efficient as possible and you can be in a good shape to fly. The other note I will make is there are points recognized, typically they're for Wednesday for being prepared to fly, bonus points. We were adjusting our schedule because this was a delay due to weather. So don't be concerned about the bonus points. We'll take account for that. But that does mean you still need to be prepared because bonus points will expire just like they do in the rules. Thanks, everybody. We'll see you tomorrow at 4 a.m.
Hey, Dustin here again. If you didn't hear the news earlier, we did scrub the launch range for today. No students allowed here, but we are going to open up at 4 a.m. tomorrow instead of 5 to give you 2 hours to hopefully hit that sunrise launch. Best launch ever. Took us 5 years of trying to get one to go last year in 2019. Go ahead and check it out. But in the meantime, I'm here with Tony. So why don't you tell us about yourself?
My name's Tony Alcacer, and I'm a Rocketeer. I'm the range safety officer for this event, and I think I started in 2015, so 7th or 8th year. I'm not good with math. Range safety officers in charge of a big group of people or a team, and we're in charge of making sure it's very safe, or safe as can be out here. I'm also one of the people that build all the stuff out here. So.
Nice. And where did you get all your rocketry experience?
I started as a kid flying Estes rockets. When my kids were little, we flew Estes rockets, little cardboard things flying on little black powder motors. When my son AJ was 13 years old, 20 some years ago, on the internet, something called the internet, and he asked me, hey, look at this, and my thing was, we can buy those? And so then it just went from this size to this size to this size to this size to buying drums of chemicals and lathes and making everything from scratch. So.
Awesome, thanks. Well, why don't you tell us about what's standing back here?
So this is one of our pads. We're currently in the solids area, and this is either bank A or B, and the one across the way is the opposite bank. There's 6 pads here. We're able to launch 8 rockets here. The reason we only provide 6 is some of the teams actually bring their own pads out here and stuff. And so if you know anything about Estes rockets, that they need some guidance when they first start taking off. And usually with Estes, it's like an 1/8-inch rod and stuff. And so as your rocket gets bigger or faster, you need to either make a bigger rod or a rail. And so if you look at this here, there's an 1.5-inch square piece of aluminum with slots in it. And this particular one is 17 feet long. And as an example, that the rocket would have a button on the side of it similar to this. This is not the button, but the button would go inside this slot. And there'd be 2 of these on your rocket. And then a stop. Goes on behind that to hold the rocket in place. This thing is raised up. Everybody's evacuated from the area. The electronics, GPS are all turned on, and a dual igniter is put into the rocket. And so each rocket has a redundant system, 2 flight altimeters. It's going to have probably up to 4 either black powder or CO2 charges. Everything's redundant, including the igniter. We have a dual igniter in case that first one doesn't go, the second one's the backup, because we want these to go. And so once the rocket's fired, it's in the vertical, that these just slide along here. And there's very little whip in this. Part of the design of this is some of these motors will produce 1,000 pounds of thrust. And so with this in the upright position, the motor's going to have 1,000 pounds of pressure pushing down on this steel plate, which also stabilizes this whole thing. It's staked into the ground with 36-inch rebar and stuff. We want this to stay where it is, and we want the rocket go to where we're pointing them. We're not aiming them, we're pointing them.
Awesome.
What's the difference between aiming and pointing?
Political correctness.
Nice.
Of course.
Can you tell me about what that is in the background and how we use it?
This launch is very unusual in that we can't actually see where the launch control center is, which is up on an overseas container. So it's about 10 feet off the ground, and we can't even see where it is. Hence, they can't see us. And so we control our activities out here via radios and a series of flags. That's a flagpole. A green flag means that this range is open. If you have business on the range, proceed out to the range. If there's a yellow flag up, that means that the electronics are being armed and the igniter is being inserted. And only certain people are allowed at the rocket then. If there's a red flag, that means that rocket launching is imminent.
Awesome. And then, can you take us through how the launch control system works?
Yes. So we have a bunch of extension cords out here that feed to a wireless box that's going to be sitting on the table there. and by magic and radio waves, it's going to transfer the signals. I think we're 3,500 feet away to the Launch Control Center. They'll be able to see that rockets are attached to each of these leads and that the igniters are showing as a good connection and stuff. And then once we get everything inserted, the igniter's in, we turn this over to red, we vacate the area, and then we transfer all activities to the Launch Control Officer.
So how do they know that the igniters are all wired and going to actually work, and that there's no break in the lines?
When they push the button and it works, then it's right.
Nice.
And so sometimes there's as many as 4 wires, and these college students, or some of them are mechanical engineers, and actually get the wiring wrong. So it's very good training.
They're mechanical engineers, not electrical engineers.
That's true. So this is real earth training, whether it's weather, whether it's dirt and mud.
All right, well, I think that's about all we have for you out here at the pads. So stay tuned. We got one more interview planned before we cut the live stream. Go ahead and kick it off to something else.
All right.
Animals to avoid in the New Mexico desert, or How to Minimize Pain and Suffering Part 2.
Hello Rocketeers and welcome to Spaceport America Cup 2022. One of the items we need to be concerned about here in the desert is wildlife. And the wildlife that isn't always obvious can be some of the most dangerous wildlife, like a rattlesnake curled up in a bush. That's why we wear our jeans. That's why we have closed-toe shoes and even boots if we can have them, because you never know where you might run into a snake like this one.
Other animals to watch out for. We have some fearsome looking but harmless creatures around here. Our best advice: wear boots, wear jeans, pay attention to your surroundings, and if it moves, leave it alone.
Hi, it's Dustin again here out at the range at Spaceport America Cup 2022, brought to you by Sierra Space. As you should already know, we are closing the range for flights and everything today, but we did do special opening 4 a.m. tomorrow, so get here as soon as you can at 4 a.m. You'll have 2 hours to hit that 6 a.m. morning launch and get that early bird award. In the meantime, we just got done interviewing Tony a little while ago at the rails. Once the teams are done launching their rockets, they have to come here to check in. And so with that, I'm going to hand you over to Chris with Da Vinci, and he's going to take it from there.
Hi everyone, I'm Chris with Da Vinci Maker Labs, and welcome to the recovery tent. So, teams have just launched. They're going to come over here, and they're going to get one of these cool packs. Stylish. So, stylish pack, of course, you know, ESRA patch on it, right? So, this pack is pretty special. It does two things. It allows us to talk to a team and track a team. So they've launched a rocket out into the middle of this wonderful desert. We need to know where they're at. We need to know that they're safe, healthy, and so forth. Get them in, get them back. So anyhow, they check out a pack, we communicate with them, they come back here, and then they move on to another section of post-flight, and then now we're going to show you the behind the scenes of that pack, all the communication stuff. So let's go that way and check it out.
And while we're walking, it's not just the behind the scenes of the communication pack. They are running all of the flight communications. So anytime the pads are trying to check in, check for signal, check in with LCO, then he has a whole nother network for the ESRA judges for, you know, if they need trash bags or they have questions on judging or anything like that, they can radio on that whole network.
So those are all radio networks that Dustin's talking about. If you look right up there, there's one of our antenna arrays. If you come on around here, so up there is a tracking antenna for tracking rockets, for tracking packs, 2 repeaters, and several other receivers and transmitters we use for all the different voice networks. We're going to cut through this line right here. Come on, let's go this way. So as you approach the trailer, you can see all the feed-throughs, all the cables, go to the antennas. And if we take our heads and poke in here real quick. Okay. So in here we've got 4 stations. The stations are recovery, flight, Ops 1, and Ops 2. So whenever someone calls in, a customer calls in via voice network, they get one of these operators. These operators can communicate with each other to pass traffic from network to network, but they can also use an integrated database and other tools that are very difficult for people in the field to use. As you can see, this is inside, it's comfortable, they have workstations in front of them. When you're in the field, not so much. So the whole point of all of this is to make our users out in the field more comfortable and provide the information that they really need to do their jobs well. So it's a support mechanism for the ESRA folks in the field. And then after they've done the recovery pack situation and these guys have communicated all their stuff, now it's time for the team to go over to post-flight and basically get scoring for the rocket. And then we're going to go check that out right now. This way.
Got you some branding there on the side of your trailer.
Ah, yeah. All right. So it's empty right now, but these are the lanes that are the students will get in and queue up to go out to the pads. Obviously you already saw the rails and so forth, but like I said, when they come back, they're going to come all the way back around. They're going to hit this tent right over here. This is Randy with post-flight. They're going to bring their vehicle in here. They're going to download all their data off their altimeter and so forth, dump all the data to this gentleman. He's going to get it entered in our database, and then after the event we pull all that down. It goes to ESRA and they combine it together to do their scoring and so forth. And that is basically the end of the process of the rocket operation.
Would you like to expand on what you're looking for during the post-flight inspection?
Well, during post-flight inspection, what we are doing is determining whether the rocket is suitable to fly again. So as long as it does not have excessive damage, that is anything broken or fin missing that would keep the rocket from safely flying, then we accept it. It could have superficial damage, but we are not concerned about that. And that's the choice between excessive damage and non-excessive damage.
Cool. Well, before we go ahead and cut, why don't you tell us about DaVinci Maker Labs?
So DaVinci Maker Labs is pretty basic. It's a makerspace. It kind of got augmented because we're really involved in rocketry. We do a ton of mentorship for students in aerospace and rocketry, and it really fits with ESRA. And as you all know, or a lot of you know, the rocketry community is pretty tight. So we all kind of know each other, and there was a requirement to do some communications. So we started doing that, and we just kind of fit the bill. So, but as far as DaVinci itself, again, it's just a makerspace. It's kind of a cool makerspace because we have all the toys to make great big rockets, which is great. It's in Alvin, Texas, just south of Houston. You should totally check it out. We do have classes, and we do have online classes, which is very cool. So if you're into building motors and things like that, you should check us out. We'd love to have you.
Well, one last reminder to the students. If you follow me here a little bit, the reason we're so intent on trying to get you off the rails at 6 a.m. is that mountain range is right over there. That's pretty much where the sun comes up, at 6 a.m. So if you get here at 4 a.m., you have 2 hours to get on that rail. Whoever's ready, we pull back, we launch whoever's ready to get that perfect sunrise launch. So please get here by 4 a.m. And the guys in the trailer, go ahead and cut to another amazing student video, or something besides me, please.
I love it. It's like the live production.
My name is Justin Kissel. I just recently graduated with a degree in computer engineering from the University of Michigan Dearborn. I'm the current president of NASA Dearborn, the school's rocketry team. In the past, I've held the role of electrical lead just before I was president this year.
Hello, I'm Joshua Hawkins. I am a third-year electrical and computer engineering dual major here at U of M Dearborn. Right now, I am the electrical lead of the team, where I handle a lot of just project management of all the electrical projects, and then help teach a lot of the newer members how to do most of the stuff that we do on the team.
Hello, my name is Sarah Dormal. I'm a third year at University of Michigan Dearborn, and I'm the current mechanical lead for MASA, and I was the former airframe lead for MASA. This year I've been working mainly with manufacturing and doing fins and all sorts of aerodynamic study and leading the team to manufacturing on time and completion of our project.
Hello, I'm Sierra Stockwell. I'm in my fourth year of my mechanical engineering degree at the University of Michigan Dearborn. I am the current business lead of MASA Dearborn. I I have previously held the positions of president, mechanical lead, and payload lead, and this year I have focused on sponsorship, recruitment, fundraising, purchasing, as well as an L1 certification class, the new member payload, and CNCing all of our CNC mill parts.
MASA Dearborn is U of M Dearborn's rocketry team, founded in 2015. We've competed in Spaceport America Cup 5 to 6 times now, including COVID. We get sponsorship from the University of Michigan Dearborn CCS department, as well as local automotive companies, as well as aerospace companies from around the U.S. This is 2 Boosted 2 Bear, the first rocket MASA Dearborn successfully launched at Spaceport America Cup. This rocket successfully launched and recovered up to 11,000 feet. Some of the special things it had on it was it had deployable wraparound fins, custom designed by one of our members, a composite static fin that we actually still use currently, which is a sandwich composite with 3 layers of carbon fiber, a layer of aluminum honeycomb, and then 3 more layers of carbon fiber pressed together. And then this was powered on a solid propellant motor, a solid propellant M motor, which is very similar to what we're using this year. This was the payload for that year. You can see it contains custom electronics, and this is in the custom von Karman geometry payload. This year we have moved to the CubeSat payload, which is why we've gone up in diameter. However, this payload conforms to the geometry of the nose cone, allowing more to fit right up in the nose cone of the rocket. This is Boosted Bear, the next generation. This was the rocket that was used for the virtual 2020 Spaceport America Cup competition. This was just a virtual competition, so no manufacturing was involved. It was design only. And in the 10K COTS category, we placed 10th and we placed 22nd overall in the entire field. Some special things about this rocket. In our payload here, you'll see it still maintains some of that von Karman geometry with the curve towards the top, fitting into the nose cone. You'll see right now it just has a ballast payload in it, but this is running a microorganism experiment as well as custom electronics and cameras, which are very similar to what we're running this year. We're running the same type of camera, just using a Raspberry Pi Zero, and this is housed under this carbon fiber camera shroud. We have a very similar design this year, however, with some refinements to increase our video quality and increase the ease of integration. This is MASA's custom GPS. This is a custom secondary tracking solution, secondary to our COTS GPS, the tele-GPS this year, and we are looking into making this our primary GPS in future competition years. We also have the Power Management System Mark III. This is in charge of providing power to all of the boards in the board stack, which include the flight computer as well as the experiment data board. The flight computer is in charge of handling the air brake control loop, which tells the air brake blades when to extend and how much to extend, as well as controls all of the data flow inside of the payload. We have the experiment data board. This takes all of the data directly from the experiment and also controls the servo to help with the valve actuation. So this contains all of the data and runs the actual experiment. And then here is the GOAT, or the Global Operational Air Brake Tuner. This handles the actual actuation of the air brakes, so it receives a signal from the flight computer to actually move the motor to extend the air brakes.
So what we have here is basically the setup for the air brakes electronics, where we have the Global Operational Air Brake Tuner, or the GOAT, as I like to call it. Basically just turning an example for the air brakes assembly we have. Currently, this was last year's setup that only had 3 blades. However, the current year's setup is going to have 4. Right now, I'm just telling it on our custom-made board to open all the way open and then close.
MASA Dearborn's current project is Project Hazmat. It is a boosted dart configured rocket going to 10,000 feet, but is capable of 30,000 feet and hoping to go to the 30,000 foot competition in the next competition year. Some special features of this rocket: it includes a CubeSat payload, which contains a reaction experiment testing an SRAD valve system built by the students on the team. We also have air brakes in the rocket, which help refine the apogee to as close as possible to that 10,000 foot target. We also have reefing systems on both of our recovery devices. So for the booster and the dart, we have a reefed parachute that is custom sewn by us and using tender descenders to deploy from drogue to main. We also have a new member certification class. One of the main focuses of MASA Dearborn is on new members and learning. So we put together this level 1 certification class in order to teach new members, especially new airframe members, about the basics of building rockets at a smaller scale on H's and I motors before moving up to a vehicle that weighs 60 to 80 pounds on an M or an N motor. MASA Dearborn has entered in Spaceport America Cup to help further our engineers' education by applying all of the theoretical knowledge that they learn in classes to a project that moves from design to manufacturing to integration and testing, all while completing milestones that happen in industry like PDRs and CDRs while writing technical reports mandated for competition.
love the chase and the hunt, and I set the pace when I'm running. I always take what I want and I always give it 100. Don't need a bank, no I'm funded. Play the game like it's nothing. I'm always thankful for something. Don't take for granted, stay humble. Now wake up! It's time to look at the enemy. Look in the mirror if he is no friend to me. It's not working out, maybe it's the chemistry. It's time to break up so I can make a better me.
UFSC Joinville, the place where in 2013 Cosmos rocketry was born, and which today is the place where we acquire knowledge to help us build our rockets. And like every successful team, we keep searching for higher flights. And today the college lab is not our sole workplace. Through partnerships, we now have access to Fab Lab and all its structure, to Agora Tech Park, where we managed to close large partnerships that have brought us to where we are. We also hold meetings and events at their buildings, and it was in these places and with all our partners that our VLK has begun its journey to New Mexico. VLK stands for Cosmos Launcher Vehicle, and it's our first 3 km apogee rocket, the first in our history made to Spaceport America Cup, and it's powered by our self-made engine, Koala. You can see it roar. All of our subsystems are produced by our own team, the ones that regulation allow us to do so, and tested repeatedly. Like our telemetry and motor, because in this way we are capacitating all of our team, and with all the efforts of each sector and team member, now our VLK is ready to tear up the skies in Spaceport America Cup 2022. But why invest so much time and sweat in this project? Because we love rockets and we want to bring that passion to the generations that will come, at the same time that we develop technologies to drive the space sector in Brazil. Because the future of our country is in the hands of young minds like ours, and that is why we seek to have a solid presence in social medias like Instagram and TikTok, where we can reach more people to share all the excitement of a successful launch. Plus, the rockets are pretty awesome, and between overworking and laughter, at the rocket shop and university, we put a lot of effort to be present in the biggest rocketry competition in the world. And we are proud of every second spent in this project. I can assure you that we'll be merely the first of our Spaceport America Cup rockets. Like a famous man once said, we are going and we are going to stay.
I'm the team captain.
Hi, I'm Jesse Davidson and I'm project manager.
My name's Hunter Madden, I'm co-lead of avionics.
Hi, I'm Matthew Vasiljevic and I work on avionics and body construction.
Hi, my name is Nina Musio, and I was the co-lead of the payload and aerostructures.
I'm Amelia Radetsky, and I'm co-lead of payload and aerostructures.
Hi, my name is Connor Madden, and I am parachutes and aerostructures co-lead.
Hi, my name is Anthony DiGirolamo, and I'm the avionics co-lead.
I'm Jesse Putma, I'm aerostructures co-lead.
The objective of this project is to design, build, and test a solid fuel rocket that carries a 4 kilogram payload to a 30,000 foot aperture class.
The most enjoyable part of the project for me was the construction phase and seeing our design and hard work come to life.
I think the hardest part overall was learning new materials, getting out of our comfort zone, and overcoming challenges that we faced throughout building the rocket.
The biggest challenge is the fact that we got a late start to the COVID, and everyone in the team was brand new, knowing nothing about rockets, and just trying to get an understanding of what we have to do in a very short period of time.
I wanted to join the team because I missed my chance in second year to work with the team since the pandemic started, and in fourth year I wanted to do this as my first.
I joined the rocket team to apply the knowledge that I learned throughout my undergraduate degree to design and build a rocket that was able to be tested and launched in the Mexico.
I'd say the most enjoyable part of the process was seeing the final result of our rocket. Really satisfying.
I'm proud of the University of Windsor Rocket Team because we all came together as individuals and worked as a team to one common goal of building a rocket.
I think I speak for the whole team when I say we're looking forward to seeing all our hard work pay off when the rocket actually launches off the launch pad in New